Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about OOP Polymorphism. All code examples used in the videos will be available on GitHub. Let's get started.
Remember, we talked about the OOPs concept, first class, object, and inheritance. So till now we talked about three OOPs concept: class, object, and inheritance in Java. So today we try to move with another one OOPs concept called polymorphism. Okay, so let's move with this. It's a very good and very important concept in object-oriented programming approach. Okay, so let's understand this polymorphism concept. So first point is that let me understand this polymorphism from layman's point of view. Then step by steps, I'm coming into that core technicalities. So here, what I want to say, like assume as a human being, as a student, how many person I'm interacting with full day, right? So one student, how many persons is going to interact with in full day? So he may interact with anyone, one. How many persons he's going to interact with full day from morning, right? So he may interact with parents, he may interact with son or daughter, or friend, or colleague, or office boss, or teacher, right? Or neighbor, right? So as a person, you are interacting with or some other if you are going visiting any particular shopping mall or offices, you are interacting with the people there. So the same person full day he's interacting with different category of people, correct? So same person is interacting with different category of people. Now the communication will be different with the different category of people. When he's interacting with his parents, this communication will be different from how he is going to interact with his friends. So take it as an employee. I'm going to add some more or right. So like this way you can add. Now same person is behaving with different people, right? Full day, right? Either he is from family or friend or from profession, from with boss. But each and every communication is slightly different. How you communicate with your boss is not the communication how you'll communicate with your friends. And that is not the same how you are going to communicate with your parents. That is not the same how you are going to communicate with your child. So same people is behaving differently in different type of communication that we are talking about. Same person is behaving differently, or same person will communicate differently in different communication. You can say like this, right? Same person will communicate differently in different type of communication. That means same person is behaving different in different type of communication. Correct? Yes. So the same this concept, when I talk about from Java perspective, same method will execute different task. Same method will do different task. Very simply, if I want to say, same method will do different task. Same method will do different task. This is the concept of polymorphism. Again, I'm saying, I've just given one comparison here just to understand some layman's point of view. Like same person is communicate differently in different types of communication. Same person is same, but when the communication will change, is communicator will change, communication will also change. Same like that, in Java programming, object-oriented programming approach, you'll find that the same method will do different tasks. If this is the scenario, this concept is called polymorphism. How it is? See, polymorphism came from the name called polymer. So polymer, polymer, it's a, if you know the chemistry, you'll find that this polymer is created using a particular element called carbon element. This carbon element will be available in multiple states. It will be available as a coal, available as a diamond, available as a naphthalene. Same carbon element will be available in different state. Same carbon element will be available in different state. Fine. So that is called polymer. That means same carbon element is different state. Same thing, same method in Java class. Same method will do different task. If this is the scenario, this concept is called polymorphism. If you find, and in object-oriented programming approach, we can use a particular method to implement same method to implement different task in different scenario. Okay, if that concept is called polymorphism, and this is one of the strong concept in object-oriented programming approach, right? Okay. So let's go to some more in depth on polymorphism. So this polymorphism, let's understand into more details how a particular Java method, same method is going to work different task. And if it is doing different tasks, then what is the advantage, right? What advantage I'm going to get using this concept of polymorphism in object-oriented programming approach. Last time, if you remember, we talked about inheritance. So there is a huge advantage of using inheritance, right? You can reuse the code of your base class, the derived class. That is a very important features of OOP's concept inheritance, right? Now today we'll talk about this polymorphism concept, how we can use this concept of polymorphism in object-oriented programming approach. Fine. So polymorphism type I'm talking about first. First one is called function overloading. Function overloading, or it is called compile time polymorphism. Another is function overriding, or runtime. These polymorphisms are two types in Java. One is called function overloading. Okay. Another is called function overriding. So let's try to understand this one by one. Both. Okay. Let's move with the first one first. Function overloading or compile time polymorphism. Okay. So as I just now talked about, that polymorphism means same function is doing different task. Same function is doing different task. That is the idea behind polymorphism. So let's understand this function overloading or compile time polymorphism, how same function is doing different task, right? So let's understand it using a small example. Better to understand is writing an example to understand this concept is better. So before saying anything else, let's create one program. Then I'm adding one by one. Fine. Let's create one program first. One class calculator. So inside this calculator class, we have multiple methods and we have a main class, calculator test. Fine. Now inside this calculator class, write some method of some method you can write. So int sum. Okay, I want to add int a, comma, int b. Okay, and this method is going to return the addition between two numbers. Fine. So return a plus b. That's it. Right. And I don't want to create an object, make it a static method. Okay. And static method. Now same like this, I have another one method, Control C, B. This method is returning float, and it is going to add to float. Fine. I'm going to write another one method, and this method is going to return float, and it is going to add int and float. Fine. So just see here, inside the calculator class, I have three methods. The static method, why I'm using static method? Because I don't have to create an object of the class to call those methods. I can directly call it. That means you have to write a main method here. String args. Fine. Now save it. Okay. Now what I want, these are static methods, right? So I can call a static method directly from the main method. So you can use here sum or sum. Three methods we are using. Sum. Fine. So see here, all the method name is same. Just see here, same method name. First point, same method name. Fine. So here, now I want to do the addition between two numbers. Now these methods are available in different class. You can make it in different class, or you can make it same class also. If you're using different class, then you have to call using this class name. Right. If I'm going to use in the same class, I don't need this using class name. You can directly use if I'm going to use in the same class, you don't need a separate. So you can directly call the sum method. So that we talked about, right? The properties of a static. What you have done, a static method, you can call from the main method without class name if the main method is in the same class, right? Okay. Now here I'm going to add two number. So assume I'm going to add 4, 5. I'm going to add 4.0f. It's a float, right? Comma 5.0f. So I'm going to add to float variable. I can add, right? So I have to print it because it's returning, right? So if I'm going to add to float variable, so which method it will call? This method it will call, because this method have the argument of float. Now I'm going to add to int 6, 8. Which method is going to call? Is going to call this method because it's taking int as an argument. So if I'm going to add 7, 3.0f. So which method is going to call int and float? This method is going to call, right? Right. So what you find here, just see that same method name based on number of argument and type of argument, one of the method gets selected. Same method name, right? Based on type of argument and number of argument, one of the method gets selected during compile time. Get selected, right? Right, based on number of argument, type of argument, one of the method gets selected. All the method name is same. What I told about polymorphism. Polymorphism means same method is doing different task. Yes, same method is doing different task only. Method name is same. This method is adding the addition between two integer. This method is doing the addition between two float. This method is doing the addition between int and float. So same method name but doing different task, right? So where method name is same and based on number of argument and type of argument, one of the method gets selected during selected, right? So this we define it as function gets overloaded. One of the method gets overloaded based on number of argument and type of argument. Where all the method name is same, one of the method gets overloaded during compile time, based on number of argument and type of argument. This is called function overloading. Again, I am saying same method name based on number of argument and type of argument. One of the method gets overloaded. This is called function overloading. So which method to overload? First one, second one, or third one? Which method to overload? First one, second one, or third one? That is decided during compile time. That's why it is called compile time polymorphism. Right? So overloaded method is decided during compile time. Overloaded method is decided during compile time. That's why it's defined as a compile time polymorphism. So here it does not depend on return type. It does not depend on return type. That's why it's returning int, float, float. It does not depend on return type. Does not depend on return type. That's why we define it as so it does not depend on the return type. Okay. Now the thing is that what is the advantage? Okay, fine. We got this is called function overloading or compile time polymorphism. If this condition satisfy, then we say yes, this is a compile time polymorphism. Fine, got it. But at the end of the day, what is the advantage of using this compile time polymorphism or function overloading in case of object-oriented programming approach? What is the advantage? So advantage is not from developer perspective, it is mainly from compiler's perspective. How it is? See, when I'm going to call a particular method, because the main methods from here, the execution will start, right? So when I'm going to run a particular method, for compiler, it will count it as a single method. Okay. For compiler perspective, it will count it as a single method. Based on argument type and number of argument, type of argument, it is going to overload one of the methods, and for compiler it will count as a single method, not the three methods it is there. So based on same name method, because same name method based on number of argument and type of argument is going to overload one of the method. So from compiler perspective, it will count it as a single method that gets overloaded during compile time. So the performance is from compiler's perspective, not from the developer's perspective. Fine. So this is the idea behind function overloading or compile time polymorphism. And these are the condition, like it should have the same method, different signatures, means return type can be changed, right? Okay. And it is widely used in foundation classes. Fine. Okay. Now this is an example that of function overloading. Let me execute and check it is working or not. It's fine. Theoretically, I told lots of things, but let's me execute it. It's working or not. Calculator.java, right? Control C. Let me execute it. So create one class, right click, new class, name of use some package name as this, and here the class name is calculator. Fine. So inside this calculator class, we save it. Okay. Right click, source, format, save this. Right click, run as Java application. Now it is not printing anything because you are not printing. System dot out println. Fine. Dot println. See. Okay. So save this. Right click, run as Java application. So it's working fine, right? It's working fine. Nice. So this is an examples of if you now we can say like the sum method gets overloaded during compile time based on number of argument and type of argument. It does not depends on the return type. For compiler, it will identify as a single method, right? Not three method. Now the thing is that if you change the name, then this will be something series. Now no, I am using this one sum. This is sum 1, and this is sum 2. So what you have done, you have creating a different method name are not same, then it is not a function overloading. So in case of function overloading, in case of function overloading, all the functions will be in the same class, right? And there is no concept of inheritance. All the function will be in the same class, and all the function name must be same. Okay, that is all about fine function overloading. Fine. Okay. Now here, yes, anyone want to add something else, you can add. Now here, I want to show, okay, this is the user defined examples of function overloading. So I want to say that please show an examples of function overloading, API examples of function overloading. That means already some function overloading is defined in API. I want to see an API examples of function overloading. Let's see. I'm talking about API example of function overloading. API example of function overloading. So the example that you have done just now, that is an user defined example. This calculator class, it's an user defined example, right? Now I want to see one API examples of function overloading that already this API means already the pre-built API documentation. I want to find one examples of function overloading, right? So let's see which is the API examples of function overloading. See here. See, if you want to print anything, what do you do? If you want to print anything, I'm going to print a particular string. Okay. So what I am going to do, I'm going to use system dot out dot println, right? I'm going to print one string, right? So I'm going to print one string like this. Okay. If I want to print a particular number marks, what I'll do, I'll write like this. Okay. If I want to print a particular salary will come with decimal, assume 12000.00, right? Okay, I want to print a particular character, so I want to print a particular character like this, right? So what I'm going to do, if I want to print something, I'm going to use system.out.println method. If I'm going to print something, I'm going to use system.out.println method. Correct? So let's understand this one. Sometimes you're printing on a string, sometimes you're printing an int, right? Sometimes you're printing a double, sometimes you're printing a character. So what you are going to print, it will change, right? Fine. So let's understand this system.out.println in the API documentation. Let's understand. So system is already, we know that system is a class that is defined inside a lang package. Correct? Okay. So let's see where is system class in the lang package. We'll see the lang package, system class in the lang package. This is the system class. It is already open. I want to open once again. This is a system class in the lang package. Fine. Okay. The system class extending object class. Now the system class contain three variables: print stream ERR, input stream in, and print stream out. Right? So what I'm doing here, I'm writing here system.out.println. So out is an object of, see here, out is an object of print stream. Out is not an object of system class. Out is an object of print stream, right? So print stream out is defined inside the system class. Okay. Now you're using method called println. So println method is defined where? I'm calling out.println. That means println method is defined inside the print stream class. This print stream go inside print stream, and you'll find println method is defined inside this println method. See here, println method. Just see here, different types of println method. So different types of println method. Just see here, please. This println method is printing a boolean value. This println method is printing a character. This one printing a double value. This one printing a float value, int value, string value. So there is different println implementation to print different types of data type. Different types of println implementation is there, already given in your API documentation. So when you print a particular string, then the println with string implementation, this one is called, or this one. Fine. So we'll just give me 1 minute. Okay, so let's move with our discussion using function overriding or runtime polymorphism. If anyone have any queries, you can share in the communication window. Okay. See, this function overriding, this is also another important features. One important polymorphism. So let's understand this. Since it is a polymorphism, that means here also the same thing, like same function is doing the different task. Just now we have done function overloading, right? So in function overriding or runtime polymorphism, here also the same thing, like same function is doing different task, right? So we'll talk about this function overriding runtime polymorphism in two perspective. Just see here, please. First, we'll talk about function overriding. Then I'll define runtime polymorphism. Just see here. So to understand this, I'm just writing a code. Writing a code, we'll understand this full concept. A to Z. Just see here. Create a separate class. I can show in the slide, better to write here. Shape. This is a shape class. Okay, it's a shape class, right? First point is that runtime polymorphism or function overriding come into picture when there is a concept of inheritance. Okay, so that time this concept will come. There is a concept of inheritance. When there is a concept of inheritance, then only this runtime polymorphism concept will come. Okay. Okay. Now this is your shape class. Okay. What happened? Save. It's gone, I think. Okay. This is your shape class. Since it is an inheritance concept, so take one derived class circle extends shape. Fine. Similarly, you can write class rectangle extends shape. So you can see here there is a concept of inheritance, right? We have one base class and two derived class. So there is a concept of inheritance in case of function overriding or runtime polymorphism. Fine. So define one method inside a base class. Assume the method name is void area. This is the method. Fine. Okay. Now this method is used to calculate the area of a circle or the area of a rectangle, right? What I'm going to do is that this method, same name method, I'm going to write in circle And here I want to calculate area of a circle. I'm not writing any code, just writing in a statement. I'm just defining it. Calculate circle area. Fine. Now, inside rectangle class, I'm going to write one area method, which is going to calculate area of a rectangle. Calculate rectangle area. Fine. Okay. Now see here, same method name. Here also the same method name. Same method name in the base class and in the derived class. Right? So what we have done is that we now see same method name where method signature is same also. Same method signature, same method signature. Fine. Now how you can define it like this, that in the base class I have an area method. I've overridden this method from base class to my class with my own code. From base class to my class with my own code, where it depends on return type. That's why I've written method, same method signature. Method signature means depends on return type. If it is, then we say that area method is overridden from base class to my class with my own code. So for compiler, it will identify as a single method. So this is called function overriding, where same method name is in the base class and derived class. There is a concept of inheritance. Then we say that where the method signature is also be same. It depends on the return type. Method signature must be same. Then we say that the area method overridden from base class to my class with my own code. Fine. So this is how we define the function overriding. First part. Second part. Let me talk about the second part. Second part is called DMD. Second part is called DMD. You have to know about this DMD. DMD. So what is this DMD? DMD full name is Dynamic Method Dispatch. Dynamic Method Dispatch. DMD full name is Dynamic Method Dispatch. So what is this DMD is saying? Like, I'm just saying, what is this DMD? Assume, let me give another one example, just to understand. I'm coming into that example itself. Assume you have one class A. Okay, it's a base class. You have another one class B extends A. It's a derived class. Now you can say, you can write A obj equal to new B. Now see here, it's a derived class object. It's a derived class object. B. A is a base class object. I can write like this. Or I got a question last day. I can write B obj equal to new A. Now what I have done, derived class object is pointing out to base class reference. Our derived class reference is pointing out to base class object, right? So we never do this one. This is wrong. So what is DMD? DMD is defined like always base class reference will point to derived class object. Using a base class reference, I want to point derived class object. This is called DMD, dynamic method dispatch. So DMD is saying that base class reference will point to derived class object. This is DMD. Base class reference will point to derived class object. Okay, but the opposite, like derived class reference will not point to base class object. DMD is saying that base class reference will always point to derived class object. Now, if base class reference is pointing to derived class object, then what? Then what is the advantage? Advantage is that now this is my base class, and I can have multiple methods inside this derived class. Method 1. Okay, I have multiple method in the derived class. Method 2. I'm not writing full, just to understand. Method 3. Method 4. So using this base class reference, you can point to any one of the method in the derived class, like obj dot method 2. Using this base class reference, you can point to any one of the object in the derived class, any one of the method in the derived class. So using this base, that's why we always use this format. Using base class reference, we'll always point to derived class object. Now in your project design and inheritance hierarchy, you have a single base class and you can have multiple derived class. Each and every derived class will override the method from base class to your class. And using base class reference, you can point to any one of the method that is available in the derived class. Okay. This is called DMD, or dynamic method dispatch. Okay. Now this is the main idea of DMD. Now I'm talking about runtime polymorphism here. Still I have not gone, right? Now we have not completed this part, right? Now see here. Now I'm going to write a main class. So class main demo, and it has a particular main method, public static void main string RGS. Fine. Okay. Now here, this is your main method. Now inside this main method, what I'm going to do, just see here, please. I'm creating an object of shape obj equal to new shape. No issues. We are getting a shape class object. It's no change, right? It's normal. You're getting a class object. Or you can create circle C equal to new circle. So you're creating a normal class object. Nothing is going to change, right? So I'm not saying this one. I'm saying shape obj superclass reference will point to derived class object. Derived class object, which one? New rect. Shape obj equal to new rect. So what we have done, superclass reference is pointing to derived class object. Now if I'm going to call obj dot area, which area to call? It's an area of the base class or it's an area of the derived class? Which area to call? That is decided during runtime. It's an area of the derived class, rectangle, right? So that is decided during runtime. That's why we define it as a runtime polymorphism. So let me tell you once again. This function overriding or runtime polymorphism that I'm going to define here into two parts. It's a polymorphism. Polymorphism means same function is doing the different task. But the scenario is here there is a concept of inheritance. So what we have done, same method we have overridden from base class to my class with my own code. Then we say that the area method gets overridden from base class to my class with my own code, where method signature is same, means same return type. Now creating an object of base class, I'm going to point to the derived class object. That means DMD. Runtime polymorphism will always follow the concept of DMD. And creating an object of base class, shape obj equal new rectangle, I'm calling obj.area. So which method to call? Area method to call. It's an area method of the base class or area method of the derived class. That is decided during runtime, that it is an area method of the rectangle class, right? So this is decided during runtime. So from that perspective, it is said to be as runtime polymorphism. So what is the advantage to the compiler? It is mainly from compiler perspective. For compiler, it will sorry, for JVM, it will identify as a single method during runtime, not count as a method in base class and derived class. For JVM during runtime, it will identify as a single method during runtime. So that's why we define it as a runtime polymorphism. Okay, runtime polymorphism or function overriding. Fine. So this is all about function overriding. This is one of the important concept of polymorphism. So now if I'm going to change some different method here, if I'm going to change some different method, then it is not a part of function overriding. You are getting a separate method. You are not overriding the area method from base class to a derived class. Right? In that case, you have to keep same method in the base class and derived class. Then only we can define the concept of function overriding, or we say that the method gets overridden from base class to the derived class with its own code. And then using base class reference, I can point to any derived class object and which method to call in the derived class object that is decided during runtime. That's why we say it is a runtime polymorphism. Fine. This is all about runtime polymorphism. So it's mainly from JVM perspective. Now, let's talk about an API examples of function overriding. Okay, let's talk about an API examples of function overriding. Okay, let's talk about an API example of function overriding. API example of function overriding. So API examples of function overriding, how we can define. right? API examples of function overriding. So let's take an example. Let me give one examples of API example of function overriding, like one println method. Okay. Or if you remember that object class we talked about, right? Object class talked about, remember this object class. So inside this object class we have one of the method called toString method. This toString method. Okay, so this toString method is already defined in the object class. So already told you what is object class. Any class by default extend another one class. Any class in Java, you create any class in Java, by default it will extend another class that is called object class. So this object class contain total 11 methods. You can see this object class is defined in the lang package. So now I want to define an example, API examples of function overriding. That means I want to override a particular method that is already defined in the API, in the object class, right? So how it is, right? So just see here. Let me talk about this example using some class called department class. Take a department class. A department class. Let's understand using a separate class better. So right click new class and assume it is defined inside a particular package. Class name is dbt. Fine. And it has a main method. So it is a department class. Fine. So what I want to do here, I want to write private int dbt id, private string dbt name, private string dbt location. That's it. 3 instance variable is there inside the department class. Fine. Okay. Now we can generate right click source and getters and setters. Right click source, generate constructor using fields. Right. Okay. Fine. Now this is the department class that have getter, setters and constructor. Right. And the main method is also there. Fine. So what I'm saying is that now I have to create an object of department. So create an object of department dpt d equal to new dpt. I have created an object of department. After that, d dot system dot out dot println. I'm going to print the department object. Create the department object using that parameterized constructor. Here I have the parameterized constructor, right? ID, name, and department location. So ID assume 12. Department name assume it is sales, and department location assume it is in Bangalore. Fine. Okay. So this is done, right? Okay. Now here, fine, right? Okay. So it's a department class as you see here. Fine. Okay. Now what I'm going to do, I'm going to print this department object. It's a normal class that have instance variable, getter, setters, constructor, and I'm going to print that department object. Fine. Just I'm going to print the department object. Just see what is the output. Right click, run as Java application. So just see here, when I'm going to print an object, class object, it is going to print an object address in the heap. Okay, and I'm going to print an object, it is going to print that object address in the heap. Fine, right? Not human readable. So what you have to do is that I'm going to override the toString method in the object class. By default, this department will extend object class, right? That object class contain toString method. Just see here, this object class contain toString method. What is this object class? This is an object class. This object class contain toString method. This is a toString method. This method I want to override from the object class to my class with my own code. Fine. So just right here, right click, source, override toString. Okay. Just see here, toString overloaded. Now I want to since I have overridden this method from object class to my class, and I can, if you want, you can change this method, like you are going to print dpt id plus slash dpt name plus slash then dpt location, right? Like this, right? So save it, right? Now here, save this. Now this is toString method. I have overridden from the object class to my class with my own code, right? Save it. Now here, now you will print this. Now let me execute this. Let's see how it is. Right click, run as Java application. Now see, if you execute, you are not getting that hash code. You can see the details, right? So what happened? So if you have a twist, if you don't have toString implementation, right, and if you're going to create a particular employee, or if you're going to print an object, then you'll find the hash code, means object address. But if you have provided this toString implementation, then if I'm going to execute this code, first it will check whether you have provided toString implementation or not. If it is not there, then it will print the object address. If it is there, then it will override this toString, and based on the output, it will represent the toString output itself. Right. So this is this we do in our object-oriented programming approach, and it's a very good examples of API examples of function overriding, where we have overridden the toString method from the base class object class to my class with my own code, right? And when I'm going to print a particular object, first it will check whether that toString implementation is there or not. If it is not there, it will print that has object address. If it is there, then it will call this toString method and print the details based on the toString implementation, right? So it's a very good example, API examples of function overriding, and we use it in our object-oriented programming approach multiple location.